Hey guys, and welcome back to another video on a simple Python where we're going to explain a concept as simply as we can. Just before we start, if you want to hit like and subscribe, that would be amazing. At the moment we're doing 2 videos a week with a short or 2 in between as well. So in this session we're going to be looking at the idea of a generator expression here. These are pretty interesting. If you've not seen generators before, they have a really useful place in the Python ecosystem. And we're going to explain what they do using kind of like a real life scenario here. So our scenario is, I've done a mock-up function for this, but imagine we have a function which takes significant computations. Maybe it's doing a web request, so it's using a request library, or it's doing a mathematical computation which takes a lot of time. And imagine we're repeating that computation over some values. So in this case here, I'm going to set up like a mock version of this. So my function takes an x, just gives it back at the other end, doesn't do anything, but it sleeps for a second in the function. And what I want to do is say, okay, do this for everything in this here. And I want to show you the difference between how a list comprehension would do this versus how a generator expression would do this. So the first thing we need to do is set up our normal situation. So I'm going to say LC for list comprehension. And we're going to do costly slow func of I. So we're going to pass something into this function, pass in I, for each I in values. So if you envision this here, we're basically saying pass this, and this, then this, then this, pass them into this function. It's going to come out the other end after doing a wait. So we should in here just see 10, 20, 30, 40 with that added sleep in the middle here. So let's see how Python chooses to do this one. Bear in mind we haven't specifically said, so if I just did this here, just check this, see that that's the program running now. I've not asked for the values, but Python is still choosing to go ahead and effectively compute all of this, store it in memory. So of course, if we were to print it, we should see it wait approximately 4 or so seconds before we see the results on the other side, and there we go. Now, in some situations, this is fine. If it's not a super costly function, yeah, it's no problem at all computing them all up front, storing them in memory and just dealing with them that way. However, there is a better option, especially if you're not using the values straight away, and that is to use a generator. And the most important thing to note about a generator is that they do something called lazy evaluation. This means that the results are actually only computed when they're asked for. So you could say, just pretend that this was a generator expression here. You would set this all up, but this wouldn't actually be called until we actually ask for the values later on in the program. So what I'm going to do, I'm going to remove this, bring this downstairs a little bit, and let's change this to GE for generator expression. Now to switch it from a list comprehension to a generator expression, all you do, change these guys into rounded parentheses, and let's print GE underneath here. Now bear in mind, when I ran this as a list comprehension, we waited 4 seconds and we saw some stuff. Now let's hit run. We're done straight away, and we see this here, this generator object gen expression, that stands for, at some memory address. So we haven't printed our results yet. Now the way to get a result out of this, there's 2 main ways of doing it. I can show you here. If you run dir, we'll show all the attributes of this object, and I'll just so I can pinpoint the 2 we're interested in. The first one is iter. That means that this is an iterable, so you could do potentially for I in GE, print I. Whether you would want to do that, I'm not too sure, because that's going to go through one by one, but just to show that it's possible, you could theoretically do this for I in my generator expression, print off each I here. So if we do this now, it's going to compute them one by one and yield them until the end. And then it's exhausted, and then it's done. However, I think where this really comes to light is with this guy here. This is the next sort of dunder method. And this is called by the next function here. This is a built-in function in Python, and it goes to the object and asks for this guy here, this next. So you can think of it as like this next function is a wrapper around this here to some degree. Just like how print is a wrapper around sort of str. It's like a nice interface to it. And what next does, next basically asks for an item to come out, and that's it. So if I did print next of GE, I'm just saying, yield me an item. Just give me one of them. So if we hit run, we get the 10. If we do a couple, let's see, I'll just clear this terminal here. We're now saying, give me 3 items. So now it's computing them as we're asking. That's where the lazy evaluation bit comes in. It's only actually calling this function when we're doing it down here. So nothing about line 14 touches this whatsoever. It's only 15, 16, 17, which actually makes that happen. One thing to be aware of is that you can exhaust a generator. So just to prove this, let's actually kick it out this way. So suppose our generator is only considering 10 and 20. So this is going to do 10, 20. So at this point here, it's going to be exhausted. So when we ask for the third item, it raises what's called a stop iteration error, just like this here. So what you may want to do, if you're in the situation, is to try and catch it. So you can do a try and except block and try and catch this here. So if I was to kind of mock that up, what you could do is to set up a quick for loop. So let's make a for loop to go 3 times. I'll do it without the exception first, just so you can see what happens. So 10, and there we go. So 10, 20, and then this stop iteration got raised here. So if you were in a situation where you wanted to catch that, just do this, try, except, I'm in VS Code, so mine suggests it for me, which is quite nice. It stops me spelling it wrong all the time. And let's say oops here. Not very creative, I know, but just to kind of get the point where a try and accept can catch this. Pick up a bit for you, and there we go. So 10, 20, and then oops here. So the oops happened because the stop iteration was raised, because the generator was exhausted, there's nothing yet left to yield, and then this happens here. One more thing I want to show, just quite neat. You can think of this as almost like a little TV show. It kind of, to some degree, you can kind of play and pause it as you go along. So you could ask for an item, you could print off some stuff, you define some variables, and then come back to your generator and resume it like this here, and that's absolutely fine. 20 there. So these kind of have almost like their own memory, so that they know what's been taken out, and of course they know what's left here. So we ask for an item, we do some other stuff in Python, and we say, oh actually, can you come and yield me another item from the generator? And it's quite happy to do so. So to wrap things up, let's just get rid of this here. I'm going to quickly bring this back here. This is my original LC. So your differences, visually, not a huge amount. You've got square brackets for your list comprehension, rounded parentheses for your generator expression. The big difference is in the evaluation. Your list comprehension evaluates everything sequentially, and your program won't move on until all evaluators are accounted for. Those things are then stored in memory. With your generator expression, they're done with a lazy evaluation. So that means that none of this is evaluated until you ask for it, and you ask for it by using the next function like this here. Cheers for watching, guys, and have a great weekend.